Previously, we built this little quadcopter that can fly for over 20 minutes on a single 18650 battery, and it retains a ton of power and flies amazing. But it had one big problem: the analog camera. Analog cameras are great because they're cheap, but they just don't have super good quality. You get a lot of interference, and on these little ones, the VTXs just don't give you enough power to get really long range. There were a ton of you down in the comments asking for a digital version of this quadcopter, and it totally makes sense because it would fix the camera problem with analog, and many digital systems can get a lot of range. I decided to post a poll on my YouTube page, and this is the results. DJI O4 Lite won by a landslide. So that's what we're gonna do. Now, how will this quad perform? On one hand, DJI O4 Lite claims to have up to 10 kilometers of range and is known to have outstanding video clarity. However, it's a little bit heavier and the VTX is power hungry. Will that negate the extra battery life? Today, I'll show you the full build process and we're gonna give it a thorough testing. Let's start with the first major hurdle, sourcing the DJI Gear. I'm located in the US, so this stuff is a little bit like contraband. When I saw you guys wanted a DJI build, I was a little worried if I'd even be able to get the parts. But after a little bit of research, I found that the DJI O4 Lite, the actual air unit, was surprisingly easy to order. I simply ordered it from getfpv.com. They had a ton of stock, and I'm not really worried about the future because Flywoo is basically rebranding these things to get them into the US. But again, I needed to snag some goggles, and I decided to go with the goggles N3 just because they were a really good budget option for $230. These goggles were much harder to find than the air unit. I found that there were a few suppliers who had them in stock, but they were upselling them for almost double the original price. But with a stroke of luck, I ended up getting a kit with the DJI Neo that came with the goggles, and it was on sale for $420 on Amazon. Then I sold the Neo for $240 on Facebook Marketplace the next day. So I only ended up paying $180 total for these goggles, which is a total steal. If you're in the US, your safest option may be to find a US seller on eBay or buy used locally. However, I did see some online retailers selling them for around $250 to $300. Whatever you do, make sure you do your research and find a seller that's legit. Jumping straight into the components, this is a Crux 3-inch frame. It's cheap, light, fairly durable, costs about $6 and weighs around 5 grams. I'll be using these HGLRC Spectre 1202.5 11,000 kV motors. After a bunch of testing, these seem to be the sweet spot to carry an 18650. Any motors of the same size and similar kV should work just fine. I found that Gemfan Hurricane 3018 bi-blade props work great. They're a good price, have a good balance of efficiency, power, and performance, and are pretty durable as well. I'll be using this Beta FPV Matrix 3-in-1 flight controller. It weighs about 4 grams and will pair perfectly with a digital system. The ESCs are rated for 12 amps, which should be plenty. It comes with some mounting hardware. We're only going to use the grommets in there, and then this 6-pin connector to connect to your digital system. Here's the DJI O4 air unit. Let's open it up. People claim this is the best digital FPV system on the market with a listed weight of around 9 grams. The air unit with the flight controller weighs collectively 13 grams, while my analog setup weighed about 6 grams. It comes with some bolts, rubber spacers, and this mounting piece here. Depending on which canopy you use, you may or may not need it. I found this 3D printable canopy that I'll link below. It's lightweight, seems pretty durable. I also like how it's slightly raised, and I hope it'll keep the props out of view. For the 18650, the most important thing is to get one that has at least a 20 amp discharge rate. This is a Molly cell here, has a 35 amp discharge rate. This is called an Amprius. It has a 10 amp discharge rate, so this one's gonna perform a lot better. Rule of thumb, try to get at least 20 amp or higher discharge rate. The higher the better. I would recommend getting something like a Molly cell P28, P30, Ampace JP30, or even Sony VTC5D. Stay away from anything on AliExpress or anything with outrageous claims. They're fakes and will not perform well. A direct connection to the cell is key for high power output. I would urge you to spot weld instead of soldering and to use pure nickel or copper strips. I will be making a tutorial video in the future on how to build one of these 1S batteries with a spot welder, so hold tight for that. Here's a quick update on the batteries that I've been making. Some of you have been asking about it. Is that I have finished some and I'm really proud of how they turned out. The quality is great. They work awesome. But it's just not worth it to make these, and definitely in small quantities. So once these are gone, they're gone. They'll be on my eBay store for a short amount of time. You can buy them if you want. I'll also be selling the Molicel P28B cells at a good price on the eBay store if you're interested in making your own battery. And like I said, a tutorial video will be coming soon. I have also designed 3D printable 18650 battery holders that fit these pre-made batteries perfectly, and they have nice protective ends that help them from getting banged up. I recently added a platform on the bottom so that the quad stands nicely. The files will be publicly available, but if you don't have a 3D printer, I will be including a pair with each set of batteries bought. To charge these batteries, I like to use my Hicito HP6 on the 1S setting at 3 amps to get a full charge in about an hour. Or if I want to charge multiple batteries, I'll use the Betaflight Whipster 3. And then you need an XT32 PH 2.0 pigtail. You can charge 6 at once at 1.3 amps. The Betaflight does have a high voltage 4.35 volts mode. Just make sure you're on the 4.2 volts mode or you could damage the batteries. Lastly, for the radio, I always recommend the Radio Master Pocket, which is affordable and feature rich. If you're on a tight budget though, Radio Master also just came out with the T8L. That is about half the price. I haven't tried it yet, but I've heard pretty good things. I always like to check to make sure that your flight controller actually works before you start working on your build. That way you can warranty stuff if you need to. Use the adapter that came with the flight controller to plug it into your computer. And Betaflight Configurator now has an online version, so you don't have to download anything. You'll plug it in, see that it recognizes the flight controller, and then move it around to make sure the gyro works. Next, I needed to update my goggles. In order for them to connect to the Air unit, you simply plug into the USB-C and then plug into your phone, go to the DJI Fly app and update it. My goggles weren't automatically on the Air unit mode, so I had to switch to that. There's a toggle button and then a back button on top of the goggles. You'll push that toggle button to the right, then click the same button down to click status. Now click over to the right and hit select on switch. Here you have all your options. Scroll down and select the Air unit. The Air unit will need to be unlocked before you can use it, so plug it into your flight controller and then plug it into a battery. Then find the USB-C port on the Air unit, plug it in, and plug the other end into your computer. Make sure to download the DJI Assistant 2 for consumer drones. There's other versions, it won't connect unless you use this one. Once it connects, it gives you the options to unlock the Air unit and you can update it. I've done both those things on mine already. Again, you'll need a battery plugged into the flight controller to bind your unit to the goggles. The LED light should be red. There will also be a little button next to it. Simply hold it down until it starts blinking. With the goggles on, hold the button down until it starts beeping. They will automatically connect and the LEDs will turn solid green. And bing bada boom, you have HD video going straight to your goggles. It turns out this canopy that I printed has the wrong dimensions and it doesn't have an antenna holder either. I decided just to design my own. It's basically an air canopy out of TPU. The files will be public if you want to print it. I'll also put this up on my store because I know everyone doesn't have a 3D printer. I'll make it nice and cheap just in case you want it. This is all the hardware you'll need. I have 4 M2 16mm bolts paired with 4 M2 nylon nuts. I would highly recommend just using the motor plugs. It'll make it so much easier. My motors don't have plugs on them because I took them off for my last build. So I will be removing this and I'm going to show you how, just in case you want to. You will get a little higher performance with a direct connection, but I think in this case ease of just leaving them on would be more worth it, in my opinion. So I simply get some kind of tweezers, rock back and forth. Be careful not to push too hard. And they just slide off like that. And then you can just take these guys, bend them down, and they'll break right off. We'll solder onto there. Oh yeah, no, these pads are a lot bigger than the Matrix 5-in-1. So that's gonna be easier than the Matrix at least. I say this every time, but seriously, get yourself a decent soldering iron. I started with an AliExpress $5 iron. I was not able to solder anything. You don't have to get this one. I just know this works great. It's off Amazon. It's a good price. That's all I'm gonna say. After quite some time of me being stupid and just breathing in the deadly toxic fumes from soldering, I finally decided to get a fume extractor. This was actually one of the cheaper ones on Amazon, and it works super well. Let me show you. It comes with these magnetic sidewalls to help extract the fumes better, but it's strong enough I found I don't even need them. First, let me show you without it. Just straight up, turn it on. Don't like to waste, but man, is that cool. Now don't forget to use flux. It makes the job so much easier. After that, heat your soldering iron up and just add little globs to it and push it up against the pads. The flux makes it so the solder just flows on. With some tweezers to hold the wire, press your soldering iron on top and it melds right together. Now for piecing all the parts together, I like to start with the battery holder. You'll put a bolt in through the bottom, just like I'm doing here, and then screw it straight into the canopy. The flight controller will go on the bottom with the DJI Air unit on top. Then I did the sides. I just lined everything up, put the longer 2mm bolts through, and screwed it on. And don't be like me, I forgot to do the VTX antenna. I would do that before you screw it on. You can see here that I was struggling a little bit, but I did end up getting it. I was just too stubborn to undo the bolts. Now there's just enough bolt hanging on top to thread a little nut. So that's where I use the nylon nuts and it just locks everything into place. Now you can see that I forgot to switch the connector. So I ended up taking that off, stripping the wires, tinning them, and then adding the XT30 connector. I opted for 4mm motor mount bolts instead of the 5mm ones that came with it. It just fit a little better. I would always recommend using a smoke stopper. It's like a $5 investment. You simply plug in your battery, it'll show a green light. You plug it into your quadcopter. If it turns red, you did something wrong and it won't fry the board, but mine was green, so we're good. I love how the battery just press fits into place really easily, and it's also a really solid fit. I also widened the landing gear to make it more stable. For the weigh-in, it ended up weighing around 48 grams, and then with the battery, just shy of 100, while the analog build was like 91, 92 grams. For anyone who wants to see the Betaflight configuration, that'll be at the end. But I just wanted to show you before I did the test flight how easy everything fits into this tiny little backpack. It's pretty awesome. That's what I love about these little quads. I even had enough room to bring a battery to use for the charger to charge the extra batteries. Right off the bat, I am super impressed with the image quality. Little full throttle here wasn't half bad either. But there was one thing I just couldn't stop focusing on, and that was the vibrations and the wicked DJI Jello. I tried messing with some of the video settings. DJI has what's called rock steady mode, which self-stabilizes as you go. That was automatically on. I turned it off and it got worse. But I still wasn't happy with this, and I know DJI is known to have this problem, and that it's mostly in the canopy. So let's bring it in and try to fix it. Right away, I noticed that the canopy could move back and forth pretty easy, and the wind was probably causing some of those vibrations. And then if you look closely on the left side of the screen, there's something under the arm kind of holding it in place, but on the right side, there's nothing allowing it to move a lot more. I simply just stuck a little bit of foam on that right side to give it a little more support. It definitely seemed more sturdy, so I'm hoping it'll work. I'll make some tweaks to the actual design later. I also found my battery holders had a serious weak point and they started to break off. I'll show you right here. I went back into Onshape and used the fillet tool to give it some more support. A quick test showed that it was much stronger and I actually had a pretty hard time breaking it. I was pretty happy with that. My last problem is overcoming voltage sag. These lithium-ion builds can run for a long time, partially because you can run them down to really low voltages. The problem with that is the lower the voltage, the lower your power as well. One of you guys mentioned in my last video to try turning on voltage sag compensation. Basically, this just means that your throttle becomes more sensitive as your battery voltage goes down, and that compensates for your battery going down, meaning the power should feel very similar throughout the whole battery. Okay, finally, to some actual flight review. There are definitely some improvements here to those vibrations. It's not perfect, but a lot better. Now, how does this digital version compare to the analog version I made previously? Not surprisingly, the analog version was a little bit lighter, and you can just barely tell there's more responsiveness and just a little bit more power. Interestingly, that version had 5 amp ESCs that were rated up to 8 amps for 3-second bursts. This HD build, however, has 12 amp ESCs, so you would figure they'd be able to draw more amps. But the most it read was only 15. To me, this simply means one of two things. The first option being the HD flight controller is limiting the amps, causing it to draw less amperage. But since they both seem to have similar amounts of power, I just think the amp meters aren't reading super accurate, and that's why they don't line up. The last big problem with this digital build is price, and you simply can't get away from that. You're getting better quality, but it does basically double the price of the quadcopter. The last quad cost me around $120 to build, and this video system in itself costs $120. It's not surprising that the image quality is crystal clear and the range is great. I'm not going to do a long range test on this bad boy until I can get a GPS on it because I do not want to lose it. However, I can say I was doing like 500 meter orbits around myself with no problem to the video signal. The radio signal, on the other hand, was struggling a little bit, so that is the weak link currently. I'd say it has about as much freestyle capability as the analog version, meaning it can do light freestyle pretty decently. However, where it really excels is being able to cruise around and explore. I felt like an eagle in the sky, actually being able to see all the little details. I was able to avoid branches so much better, be a little more confident, and go in areas I just wouldn't dare with analog. Now, the absolute best thing about this quad is you don't need an action cam. The analog version really can't handle an action cam, or it could, but it would make it pretty sluggish. This, on the other hand, it's 2-in-1. You're basically getting the footage of an action cam, and you actually get to see through that lens. Now, I think a lot of you and myself were really curious if this quad would actually be able to have good flight time with the power-hungry VTX and heavier weight. I was super surprised. It got a whopping 22-minute flight time. And that was with pretty cold 45-degree weather, and the VTX was set to max at 700 milliwatts. I would not be surprised at all if this build could go over 25 minutes in warmer weather. While pushing it pretty hard in this colder weather, I got about 13 minutes flight time, so I think it's pretty safe to say you'll get in between 10 and 25 minutes of flight time, depending on how you're flying. And I almost forgot about the VBAC compensation. I would definitely recommend it. I was getting way more consistent power throughout the battery. It won't help with the top end power, but it feels more consistent. My final verdict on the build is that this HD digital system really complements all the strengths of this quadcopter. The ultra long flight time actually lets you use the full range of the digital system, and with a lot of quadcopters, you just don't make use of it. However, it is about twice as expensive, so the budget option is always going to be analog, and it has less latency. Freestyle is a little better, just a little bit more performance. I would love to be making more content and to do it full time, so I started a Patreon, and if you're interested, you could join, and that would really help out. For Betaflight configuration, make sure you've bound your quad to your radio, plug a fully charged battery into the quad, make sure your radio is connected, have a fan to keep everything cool, and then I like to have my goggles for when I'm adjusting my OSD. To get started, place your quad on a flat surface and then hit the calibrate button. Now they've already configured everything in the ports tab, but I'm just double checking and it looks good. On configuration, we're just looking for a couple things. Max arm angle should be set to 180 so you can arm at any angle. And then make sure RX set is set to on so that you'll have a beeper, which they've already done. and you can name your quad Save and Reboot. For power and battery, I've already set all the values to what I like. I have the warning cell voltage at 3 volts because that's when I start returning home. You can go all the way down to 2.5 volts, and that's when the video feed will cut out. Make sure to hit save, and then we're going to go to the receiver tab. Simply wiggle your sticks around and make sure the quad responds to it. And I'm talking about the quad on the screen. And I'm just double checking on the top. We're set to serial UART and crossfire. This board comes with all the modes pre-configured. I'm just going to show you which buttons line up with what. Here's the arm button, top left. If you were to adjust the modes and the buttons to do what you want, you just use the little slider, and when you hit a button, it'll show the line on that channel moving, and then if it goes to where the slider is, that just simply means that's when it's going to be activated. So all of our modes are on the left switch there, and if you go all the way towards you, that's acro mode. I really like that this board has the preset ESC beeper set up to aux4, I believe, which is the button on the right. They've even already set up the flip over after crash for your, I think it's aux3, the switch on the right side. If you haven't used it before, it's really helpful, but you got to be careful, so look into how to use that. Now it's time to go to the motors tab. We're going to reorder the motors and then make sure they're spinning in the correct direction. Click I understand the risks and start. This will start one motor pulsing. You're going to find it, line it up on the screen and click on it. By going through and doing this with all 4 motors, it reorders them to the correct orientation. Make sure to click save and then go back to the motors tab. Now time to change the motor direction. Click on it, I understand the risks, and wizard. It will spin all of them at the same time. And then I simply just feel the side of the motor or the bell of the motor lightly to see which direction they're going in. And then you just follow the arrows on the screen there. By clicking the number on the screen, it'll switch that motor direction. So just click the ones you need to switch it so that they're all spinning the same way as the arrows. After you've checked all of your motors, you can just simply hit close and they should be changed. After doing this, I like to make sure that my quad will arm. You'll scroll down, push I understand the risks, and then you're going to go ahead and arm your quad. Make sure your throttle is all the way down and the motors should start up. If they don't, you might have a problem. One of the most frustrating things is when you get out into the field expecting your quad to fly and it won't arm, so this could prevent that. Lastly, we're going to go to the OSD page, and you're just going to make sure it's on HD mode, which it should automatically be on that. And then you can see all these options on the left. Just play around with it. And then you can simply click to drag stuff where you want to. What they have preset is pretty decent, so just drag it where you want on the screen. This is where I like to use my goggles so I can hit save and then see all the display information, change it if I need to, and then you're all done.